It is exciting to be able to see their project that they've designed and actually see somebody fly it, and then at the end of the test flight is to get the feedback on how it is. And it's almost like getting your test paper back at the end of an exam.
You know, you're used to seeing little bits of dirt and lots of bits of blue, and then you see a lot of dirt and a little bit of blue, and you're like, geez.
Then VLOF.
Are you kidding me?
No, that's OLAF. Welcome into the Future in Flight podcast. Coming to you from a hangar somewhere near the flight line, where the Girl Scouts have come by the FBO and we're flush with Thin Mints and Samoas. I'm your host, Shawn Staerker. In today's episode, we're packing in 3 incredible stories, and trust me, you don't want to skip a single one. First, we're going inside a competition where aerospace engineering students don't just design aircraft, they actually fly them. It's called It Flies, and it's next level cool. Then we sit down with Nate Ehlers, C-17 instructor pilot, airline captain, and the man behind Backseat Pilot training system. His story of persistence, pivots, and problem solving is exactly the kind of fuel you need for your own aviation journey. And finally, we're breaking down V-speeds, the cheat codes of flight. Whether you're dreaming of climbing in the cockpit, constructing it, or just looking up from the ground, this one's for you. We've got clearance. Let's go. You know what's wild? Most engineering students spend years learning equations, calculating lift and drag, designing aircraft on paper, and never actually get to see if their designs would fly. They graduate with degrees, but without ever feeling what their equations actually mean in the air. But what if I told you there's a competition that's changing all that? A place where students don't just calculate, they create. They don't just theorize, they test. And they don't just design, they actually fly. Now we're talking about It Flies, the aircraft design and handling competition. And trust me, this is not your typical design, build, fly competition. This one's different. This one's next level. I recently sat down with 2 incredible people behind It Flies. Amir Kosh works with Antisip, the company that provides cutting-edge virtual reality and simulation solutions. And Gordon, a retired test pilot with nearly 50 years of aviation experience, who now dedicates his time to inspiring young engineers. So what makes It Flies special? Here's Amir.
It Flies is a design, build, and fly competition, as it's in a name, where students create aircraft concepts and then they actually fly them in a high-fidelity simulator. So it matters because it mirrors real aerospace practices and it helps develop engineers who understand not just the theory, but also the behavior and performance and risks of the concept aircraft that they develop.
Behavior, performance, risk. Those are words you feel, not calculate, and that's the genius here. See, many design competitions end with paper submission, or maybe a small-scale model. But It Flies takes it further, way further. Students create their aircraft designs, code them into professional-grade simulators, the same kind used in actual aircraft development, and then watch as real test pilots fly their creations. Let me paint you a picture. You're a second-year aerospace engineering student. You've spent weeks with your team designing a next-generation business jet, or maybe a wild humanitarian aid drone, or even a 6th-generation fighter concept. You've run the numbers. You've done the math. Everything looks perfect on paper. The competition day arrives. You give a 20-minute briefing to an actual test pilot, someone who's flown real aircraft in real conditions. They ask you tough questions about your design choices. Then, they climb into the simulator and fly your aircraft. For 20 to 30 minutes, you watch your equations become motion, your theories become reality, and then comes the debrief, honest, professional feedback about how your aircraft actually handles. Gordon explained what this moment means.
It is exciting to be able to see their project that they've designed and coded for the simulator and actually see somebody fly it, and then at the end of the test flight, which is fairly short, is to get the feedback on how it is. And it's almost like, getting your test paper back at the end of an exam.
It Flies mirrors exactly how real aircraft development works. Gordon should know. He's been a part of actual aircraft development programs.
I have worked in commercial companies that actually build airplanes, and we do work with the engineers who are designing everything from the light bulbs and displays to the flight controls, the cockpits, and then all all the way through the development of the flight control system, flying it in simulators, and then ultimately we're going to strap into an aeroplane and go do it for real.
This is where It Flies gets really cool. Most engineering students never meet the end users of their designs. They don't get to see how pilots actually interact with their creations. But in this competition, that relationship is everything. Think about it. Aerospace engineers and test pilots working together, iterating, improving. That's not just a competition exercise. That's actual aerospace industry practice. And for many students, Gordon told me, this is the very first time they've met a pilot who will use what they've designed. Now, I know what some of you might be thinking. Shawn, I've used flight simulators. I've got hours in Microsoft Flight Simulator or X-Plane. How different can this really be? And that's a critical question, because not all simulators are created equal. Amir was really clear about this.
It's very important for me to say that it's very important that students use real-time physics-based engine simulators. There's gaming simulators out there as well that, although they are, they're really fun and they very visually look very nice to look at, and sometimes they have better flying experiences, but those simulators are created for entertainment. However, in terms of the physics, in terms of the data, in terms of how it processes that information, it can be incorrect.
He called it negative training, learning something wrong that you'll have to unlearn later. The simulators It Flies uses, these are the real deal. High-fidelity, physics-based systems that actually reflect how aircraft behave, the kind used in real aircraft development cycles. And here's another thing that really fascinates me. When I was studying the basics of aerospace engineering, and Amir shared the same experience, aerodynamics felt super, abstract. Lift, drag, stability, control, they're invisible forces. You can't touch them. You can't see them. You just calculate them and hope you got it right. But when you fly a simulator, a real one, suddenly those invisible forces have weight. You feel the sluggish response of too much drag. You sense the instability of a poorly placed center of gravity. Your equations become experiences. And that changes everything. Amir told me about the impact.
When I studied aerospace engineering about 10, 15 years ago, I think the biggest thing about aerospace is that you can't feel aerodynamics, and it's just an imagination that you have to understand. For me, I think aerodynamics becomes something that students can feel, and it's not just a calculation. And being able to feel and get a feeling for the lift, drag, and the stability, all of that, I think, is what the simulation adds.
From imagination to sensation, from theory to truth. Now, It Flies isn't just about validation. It's about iteration, that critical engineering skill of testing, learning, and improving. Amir explained,
and they understand about how iteration of improvement works in engineering. Iteration is a very important word, I think, in engineering. It's always a loop feedback where you go and you work on a design and you go back and you kind of feed that information again.
The first simulated flight almost always triggers major changes. Students see their design perform or not perform, and suddenly new ideas flood in. They iterate, they refine, they improve. And sometimes they realize their design just isn't going to work, and they need to pivot completely. That's not failure, that's engineering. Knowing when to change course is as valuable as knowing how to stay it. Gordon shared a great example. Students who designed these creative, wacky concepts for humanitarian aid delivery, brilliant ideas that looked amazing in presentations, but in the simulator,
when we get the briefing from them at the beginning, what their design idea is and what it's going to do, it looks good on the presentation, but somehow in the simulator, it didn't quite work. Maybe they'll come back the following year with a improved version.
That's the beauty of simulation. You can push boundaries, try wild ideas, and learn from what doesn't work without any real-world consequences. No crashed models, no wasted materials, just pure learning. It Flies happens twice a year, once in the UK, usually at Swansea University, and once in the US at the University of Dayton. Yes, that Dayton, birthplace of aviation, home of the Wright brothers. Both competitions are international. Students fly across oceans to compete, to network, to learn. And at the end, there's awards for the best flight performance, best presentation, and most innovative design. Because sometimes the boldest ideas don't fly perfectly, but they deserve recognition for pushing boundaries. The winning team takes home a traveling trophy that moves from university to university year to year. It's a point of pride, a piece of aviation history. But more than trophies or awards, students walk away with something invaluable, practical experience that goes straight onto their resumes and straight into their careers. Several It Flies alumni have even returned to work at Antisip as interns, having proven their skills in competition. So here's what It Flies really represents. It's a bridge connecting classroom theory to industry practice, connecting students to professionals, connecting imagination to reality. It's accessible. You don't need to learn anything beyond your normal coursework. Just bring in what you're already studying and apply it. It's practical. You're learning exactly what aerospace engineers do in the real world. And it's transformative because once you've felt aerodynamics, once you've iterated with a test pilot, once you've seen your design come alive in a simulator, you're not just a student anymore. You're an engineer. If you're part of an aerospace engineering program, talk to your aerospace society. Reach out to Antisip. Get your team registered for the next It Flies competition. Because the future of aviation isn't built by people who just calculate. It's built by people who create, who test, who iterate, and who turn their dreams into designs that actually fly. Up next, we meet Nate Ehlers, a former C-17 instructor pilot, airline captain, and creator of the popular Backseat Pilot training system. If you're an aerospace student with ideas that should fly, then mark your calendar for It Flies 2026, happening in the USA at the University of Dayton School of Engineering on March 28th, and then in the UK at Swansea University on June 4th. This isn't just another design contest. Teams from all around the world get to build real aircraft designs and have them flown in Merlin's professional flight simulators with actual test pilots at the controls, evaluating handling, performance, and innovation. It's a hands-on experience that bridges classroom theory and real-world aerospace engineering. Whether you're into fixed-wing, eVTOL, or cutting-edge concepts, It Flies gives you a platform to push boundaries and showcase what the next generation of engineers can do. Find out more and register at steanticip.com. That's steantycip.com. Welcome back. You know that moment when you're on downwind and suddenly everything goes quiet?
51, runway 4.
Your radios just die? For most of us, that'd be pure panic. But for today's guest, that radio failure at Long Beach Air Park back in 2011 sparked an idea that would help thousands of future flight instructors get their ratings faster, cheaper, and with way more confidence. I'm talking about Nate Ehlers, a C-17 pilot, airline captain, and the creator of the Backseat Pilot. Here's what makes Nate's story so great. He took every possible path to get where he is. Civilian flight training, regional airlines, the Air Force Reserve, military instructor pilot, and now he's revolutionizing how the next generation of CFIs get trained. Nate's aviation journey started the way a lot of ours did, with a childhood dream, 3rd grade to be exact. His grandfather was a flight engineer on B-29s during World War II, and while Grandpa never became a pilot himself, that seed was planted. Blue Angels, space shuttle launches, model airplanes covering his bedroom, the works. But here's the smart move his parents made. They told him to get a backup degree first, business school, because, and I love this honesty, Nate had never actually flown before declaring he'd be a pilot. So he got that business degree, started flying, did an internship sitting in a cubicle and realized, nope, not for him. Aviation was the path forward. But which aviation path? This is where Nate's story gets interesting, because he tried everything. Started civilian, got his ratings at a flight school in Georgia, came back to California to instruct. Then he met a former Marine F-18 pilot who told him about military flying, and something clicked.
Love the aviation, and then the military side, being part of something bigger than yourself and involved in that, and having that experience was something that really resonated with me.
So Nate goes to an Air Force recruiter, and what does she tell him? You're too old. Mid-20s. This'll never work. Door closed. Many people would have given up right there. But remember, this is a lesson for all you trying to break into aviation. When one door closes, you find another one. Nate started talking to the Marines. Then he got a job with American Eagle, the regional that's now Envoy. But that Air Force bug, it never went away. Nate discovered the Air Guard and Reserve, a path he didn't even know existed, found a better recruiter in Ohio, started taking tests, and here's the pressure. He was age critical. If he didn't make the next hiring board, he'd need a waiver that's nearly impossible to get without connections.
Just kept pushing, found a good recruiter, started moving through the tests, and at this point I was age critical. I was getting to the point where I would need a waiver if I didn't meet the next hiring board for the reserve. And it's really hard to get if you don't know someone or have a connection at a squadron. So it was kind of, we're going to take this one step at a time.
One step at a time. That's the key phrase right there. Not, I'm too old, I missed my chance, but one step at a time. And it worked. Nate interviewed with a C-17 squadron at McGuire Air Force Base, got selected, and spent the next 12 years flying the Globemaster III all over the world. Now let's talk about the C-17 for a second, because this airplane is an absolute beast. Picture this, nearly 600,000 pounds fully loaded, but it handles like a fighter. Center stick, no yoke. You can yank it into 45, 60-degree banks if you want. Tactical departures? You get off the ground, level off, pull the flaps up, and then you pull back into a steep climb that make your passengers grab their armrests. Tactical arrivals? Even cooler. You put the reversers in idle reverse and shove the nose over. 15 to 20,000 feet per minute descent rate. Nate describes it perfectly.
You know, you're used to seeing little bits of dirt and lots of bits of blue, and then you see a lot of dirt and a little bit of blue, and you're like, geez.
Then there's assault landings. 5-degree approach path into a 500-foot box on a 3,500-foot strip. Miss that box? You go around. Make it, you slam on the brakes, and the plane just stops on a dime. Air refueling behind KC-135s at night with no horizon? Low-level flying at 300 knots and 300 feet through mountain valleys in Alaska? One of Nate's sim instructors called it the Nike plane because whatever you need it to do, it'll just do it. But here's what I really want you to hear. Nate wasn't just flying the C-17. He was teaching others to fly it. And that's a completely different challenge than being a general aviation CFI. In GA, you're taking someone from zero, teaching them the absolute foundations of flight. As a C-17 instructor pilot, you're taking people who've already completed Air Force pilot training, who've done 30-some sims and a few flights, and you're bridging them into real-world operations. You're the risk management, the experience, the decision-making voice. And sometimes, you're sitting there watching a brand new pilot learn to air refuel, trying to stay calm while thinking,
Please be gentle.
remember that radio failure in Long Beach back in 2011? Nate landed with light gun signals. Got the green light. Everything was fine. But afterward, he started thinking, when was the last time I reviewed light gun signals? If I'd have gotten a flashing light, would I have been 100% sure what to do? So he made himself a reference card for his kneeboard, light gun signals. Then he thought, what else is hard to remember? What other critical information would be tough to recall under stress? He built an IFR and VFR reference card and called it the Backseat Pilot, your little helper when you need it. The goal? Modest. He was a flight instructor barely making enough to eat consistently. Maybe this could cover grocery bills. He threw it on a website, added the CFI lesson plans he'd written, because hey, maybe they'd drive some traffic and sell a few reference cards. And then something unexpected happened.
It turned out those CFI lesson plans, there was a demand for editable CFI lesson plans. And when you think back on it, you know, I didn't realize what was happening, but every time someone was becoming a CFI, you were basically reinventing the wheel.
Think about that. Every single person going for their CFI rating was spending months. Nate himself spent over 2 months writing lesson plans from scratch, not making money, spending money from loans, delaying their check ride, delaying their instructor job, maybe even delaying airline seniority, all because everyone was reinventing the same wheel. Nate's solution? Editable lesson plans. Not canned lessons you just memorize and regurgitate, because that'll fail your check ride fast. But a foundation you can customize, make your own, add your examples and teaching style to. Because here's the truth about the CFI check ride.
If you show up and read a lesson plan, the check ride's not going to go well. The DPE is going to notice, or the FSDO examiner is going to notice real fast that you're not teaching, you're reading someone else's lesson.
So the Backseat Pilot evolved, started with a reference card, became focused on CFI lesson plans with syllabi, PowerPoints, structure, everything you need, not just for the check ride, but to actually be an instructor afterwards. Especially if you're independent, not at a big school with established curriculum. And now, Nate's building digital tools, an FOI study program using AI, online lesson access, student progress tracking. He's got a specific goal he's pushing toward.
I want to double a student's confidence going into the check ride, and I want to half the time it takes to get there. That's my goal.
Not by rushing people, not by cutting corners, but by removing the busy work, by not making people reinvent the wheel, by making the path to CFI easier, not easy, because it shouldn't be easy, but easier. And here's why that matters so much. Motivation is everything. Nate's been deep in the FAA's fundamentals of instruction material lately, and he'll tell you, talent doesn't matter as much as you think. Hand-eye coordination, natural ability, sure they help, but you know what wins?
A highly motivated student will outperform a very talented student who's not motivated pretty much every time.
Flight training will cost more than you planned. It'll take longer than you expected. You'll hit plateaus when you feel like you're not learning anything. You'll have bad flights, bad landings. Everyone still has them. But if you can keep that fire burning, remember why you wanted to become a pilot in the first place, you'll push through. Whether it's for the freedom, the career, the adventure, or because you've wanted it since 3rd grade like Nate, that motivation is your fuel. So what's the big takeaway from Nate's journey? First, there's no single right path in aviation. Nate tried civilian training, regionals, almost went Marines, found the Air Guard, became a military instructor, and now he's an airline captain and an entrepreneur. Your path will be your own. Second, when doors close, find another one. Too old for active duty Air Force? Try the Guard. Can't afford flight training up front? Maybe you build tools to help others while you build your hours. Third, the barriers in aviation, age, money, background, they're meant to be understood, not feared. Nate was too old at 25. He made it work anyway. And finally, whatever you learn along the way, find a way to make the path easier for those coming behind you. Nate took a radio failure and 2 months of writing lesson plans and turned it into a resource that's helped thousands of CFIs get their ratings faster and cheaper. That's the kind of innovation our industry needs, not just from big companies and government programs, but from individuals who see a problem and say, I can fix that. If you want to check out the Backseat Pilot and see how Nate's tools might help your own CFI journey, head to backseatpilot.com. And here's a little bonus. Use the code FIFPOD, that's Foxtrot India Foxtrot, Papa Oscar Delta, for 20% off. We'll put the links down in the show notes along with that code. Remember, the aviation industry needs you. It needs your energy, your perspective, your motivation. Whether you're 14 or 24, whether you've taken your first flight or your first lesson, whether you're aiming for the airlines, the military, or building the next great aviation tool, there's a place for you here. The path might not be straightforward. It might close some doors and open unexpected ones. But if you keep pushing one step at a time, you'll get there. Up next, we dive into the language of aviation and explore all about V-speeds.
Ground Delta 887 Heavy, Kilo Foxtrot Alpha, ready taxi with Sierra.
Now, we're diving into something that sounds way more complicated than it actually is. But once you understand it, you'll feel like you've unlocked a secret language that every pilot speaks. I'm talking about V-speeds. And before you click away thinking this is just going to be some dry textbook lecture, stick with me. Because here's the thing. V-speeds are basically the cheat codes of flying. They're the numbers that keep pilots safe, help them make split-second decisions, and turn a hunk of metal into a graceful flying machine. So let's start with the obvious question. Why V? You might think it stands for velocity. And honestly, that's not a bad guess. Some sources say it comes from the French word vitesse, which means speed. Others claim it's from the German Geschwindigkeit. The aviation world can't even agree on where the letter came from. But you know what? It doesn't really matter. What matters is that pilots all around the entire world, from Tokyo to Toronto, from Sydney to Sao Paulo, all use the same V-speeds. It's a universal language. Aviation is one of the few places where everyone speaks the same technical language. A pilot from Brazil can jump into a cockpit with a pilot from South Korea, and they both instantly understand what V1 means, what VR means, and what VNE means. Now, here's what V-speeds actually are. They're specific airspeeds published by the aircraft manufacturer and certified by aviation authorities like the FAA that tell pilots critical information about what their aircraft can and cannot do at different moments. Imagine you're learning to drive a car. You learn there's a speed limit on different roads, right? But you also learn that there's a speed at which your car handles best in the rain, a speed at which your fuel efficiency is optimal, and a speed where if you go any faster, something bad is probably going to happen. V-speeds are like that, but way more precise and way more important. Because if you mess up your speed in a car, you might just get a ticket. If you mess up your V-speed in an airplane, well, let's say the consequences are a little bit more serious. Here's where V-speeds go from abstract concept to incredibly practical tool. Walk up to almost any general aviation aircraft, slide into the left seat, and look at the airspeed indicator. You'll see it's not just numbers. It's painted with colored arcs like a rainbow designed by engineers. There's a white arc, a green arc, a yellow arc, and a red line, and each one is telling you a story. The white arc, that's your landing configuration range. It shows you the speeds where you can safely have your flaps extended from your stall speed and landing configuration, called VSO, up to VFE, which is the maximum speed for flying with flaps out. Go faster than VFE with your flaps down and you risk damaging them. They're not designed for those forces. The green arc is your best friend. This is your normal operating range. From VS1, your stall speed in a clean configuration with flaps and gear up, all the way to VNO, your maximum structural cruising speed. Stay in the green and life is good. Then comes the yellow arc, the caution range. You can fly here, but only in smooth air. Hit turbulence in the yellow arc and you're asking for trouble. The aircraft might experience structural stress it wasn't designed for. And finally, the red line, VNE, never exceed speed. This is the do not pass go, do not collect $200 line of aviation. Cross this and you're risking catastrophic structural failure. In helicopters, it can cause something called retreating blade stall, which is exactly as bad as it sounds. Let me paint you a picture. You're sitting in the cockpit of a Boeing 737. You've been cleared for takeoff. You push those throttles forward and the whole aircraft starts rumbling down the runway, picking up speed. Now, in the next 60 seconds, you're going to encounter a series of V-speeds that will quite literally determine whether you live or die. Dramatic? Maybe. True? Absolutely. First comes V1, the takeoff decision speed. This is the speed where you have to commit. Before V1, if something goes wrong, an engine fails, you hear a strange noise, you see something on the runway, you can slam on the brakes and abort the takeoff. After V1, you're going flying no matter what. You're committed. The runway you have left isn't enough to stop safely, so the only option is up. Pilots train for this constantly. V1 is called the point of no return, and it's different for every flight depending on aircraft weight, runway length, temperature, and a dozen other factors. Next comes VR, rotation speed. This is the moment. The pilot pulls back on the yoke, the nose lifts off the runway, and for a few seconds, the main wheels are still rolling while the front of the aircraft is pointed at the sky. It's this beautiful, physics-defying moment. Then, VLOF.
Are you kidding me?
No, that's OLAF. This is VLOF, liftoff speed, the exact moment when all the wheels leave the ground and you're airborne. You're flying, but you're not done with V-speeds yet. Now you need to hit V2, takeoff safety speed. This is the minimum speed that guarantees you can climb safely even if you've lost an engine. In a twin-engine aircraft, V2 ensures you can maintain at least a 2.4% climb gradient with one engine dead. That might not sound like much, but it's the difference between clearing obstacles and, well, not clearing obstacles. Once you're airborne and cleaned up, gear and flaps retracted, you've got two new best friends, VX and VY. VX is your best angle to climb. It gets you the most altitude over the shortest distance. Imagine there's a row of tall buildings or a mountain ridge ahead. VX is your up and over speed. It's slower than you might expect because it's all about angle, not time. VY is your best rate of climb. This gets you the most altitude in the least amount of time. It's faster than VX, and it's what you'll use for your standard departure climb. Here's a way to remember it. VX is for obstacles. Think X marks the spot where you need to clear. VY is for why am I still climbing? Let's get up there. Then you've got VA, maneuvering speed. This is one of the most misunderstood V-speeds, but it's absolutely critical, especially in turbulence. VA is the maximum speed where you can use full, abrupt control deflection without overstressing the aircraft structure. At or below VA, if you pull back too hard on the yoke, the aircraft will stall before the wings break. The airplane protects itself. Above VA, the wings might break before the aircraft stalls. Not good. And here's something really cool. VA actually decreases as your aircraft gets lighter. A fully loaded aircraft has a higher VA than the same aircraft with minimal fuel and no passengers. Why? Physics. Lighter aircraft equals less force required to stall equals lower maneuvering speed. It's one of the few V-speeds that changes during your flight.
We'll be happy to assist you. On behalf of the crew, thank you for including us in your travel.
Eventually, every flight ends with a landing, and V-speeds are just as important on the way down as they are on the way up. You've got VREF, your landing reference speed. This is typically 1.3 times your stall speed in landing configuration, VSO. That extra 30% gives you a safety buffer. Then there's VAP, approach speed. This is usually VREF plus some additional knots for wind and gusts. If the tower reports winds gusting to 20 knots, you're probably going to add 5 to 15 knots to your VREF to maintain better control in variable conditions. And don't forget VLE and VLO, maximum landing gear extended speed and maximum landing gear operating speed. VLE is how fast you can fly with the gear down. VLO is how fast you can be when you're actually extending or retracting it. VLO is usually lower because of the aerodynamic forces during the movement. Exceed these and you risk damaging the gear system, which can make landing interesting to say the least. So here's the bottom line. V-speeds might seem like an alphabet soup at first, all these different letters and numbers and configurations, but they're actually incredibly logical. They're the result of thousands of hours of flight testing, engineering, and real-world experience. They're lessons learned, sometimes the hard way, now codified, so that every pilot benefits from that knowledge. And here's what I want you to remember. These barriers aren't there to make flying harder. They're there to make it safer and more accessible. Every V-speed is a tool, not an obstacle. Understanding them means understanding how your aircraft works, what it's capable of, and how to make the best decisions in any situation. When you start your flight training, you'll find these speeds in your aircraft's pilot operating handbook. You'll memorize them, you'll practice them, and eventually they'll become second nature. You'll feel the airplane tell you when you're at VR. You'll sense when you're approaching VA in turbulence. It becomes intuitive. Because that's the beautiful thing about aviation. What seems impossibly complex when you're standing on the ground looking up becomes perfectly natural once you're in the seat with your hands on the controls. So the next time you're on a commercial flight and you hear the pilots call out V1 rotate during takeoff, you'll know exactly what they mean. You're speaking their language now. You're part of the club. And that's a wrap on today's episode of the Future in Flight podcast. From engineering students watching their designs come alive in a simulator, to Nate Ehlers turning a radio failure into a tool that's helped thousands of CFIs, to cracking the code on V-speeds, I hope today reminded you that every great aviation career starts with curiosity, persistence, and the willingness to take it one step at a time. Speaking of It Flies, if you're part of an aerospace engineering program, this competition could genuinely change your trajectory. Head to the show notes for the link to get your team registered. And if you're on the CFI path or planning to be, check out the Backseat Pilot at backseatpilot.com. Use code FIFPOD, that's Foxtrot India Foxtrot, Papa Oscar Delta, for 20% off. Nate built it so you don't have to reinvent the wheel. Take advantage of that. And now a quick ask from me. If this show's helped you, inspired you, or made aviation feel a little bit more within reach, please subscribe wherever you're listening and take 60 seconds to leave us a review. It means a lot and it helps more aviation enthusiasts find the show. We're building something special here, and I'm really grateful you're a part of it. Thanks for being here. Until next time, we'll see you out there and up there.